10, 9, 8. Ignition sequence start. Engines armed. 5, 4, 3, 1. All engines running.
Hey there everyone. You must have heard anywhere on social media or maybe even from another person that in billions of years the sun will expand so much and become so huge that it will engulf the earth and many other planets. Well, you might have wondered, is this really true? And how does this expansion actually take place if it is also true? And what reactions take place to help this expansion happen? So, you might not believe it, but like animals have a life cycle on Earth, stars also have a life cycle in space, consisting of many different stages. So, in this video, we will be discussing about the life cycle of low mass stars. This is part 1 of 2 videos, and in the second part, we will be discussing about the life cycle of a high mass star. Now, let's discuss what low mass and high mass stars are first of all before starting. So, the life cycle of any star always starts with a body called a stellar nebula, which is a large cloud of dust and gas in space. Now, we will be learning later on how it makes stars, but for now, you should know that after the stellar nebula, all the stages of the life cycle are divided into two branches, in which the stellar nebula can either turn into a low mass star or it can turn into a high mass star, and in this video we will be discussing about the branch of low mass stars. So from the name of a low mass star we can already get an idea of what it is, a star with a smaller mass than high mass stars. But what exactly is a low mass star by definition? So a low mass star would be having a mass that is less than 8 times the mass of the sun, which means that the sun obviously will also be a low mass star. So as we discussed earlier, the life cycle of a low mass star would begin with a stellar nebula. Then it would move on to being an average star. After the average star stage, it would become a red giant star. After the red giant stage, it would become a planetary nebula and finally a white dwarf. Now here we can see a stellar nebula, which is a cloud of dust and gases like hydrogen and helium. So obviously every celestial body will have gravity which pulls things towards it. So the stellar nebula's gravity basically started to make the cloud collapse on itself, and the dust, hydrogen and helium started getting pulled towards the center of the nebula. Now when all this dust, hydrogen and helium gets collected at the center of the solar nebula, it gets really dense and hot and starts to spin, creating a large ball of fire which is called a protostar. So inside the stellar nebula, the hydrogen particles start crashing into each other and produce heat. Now, when they produce heat, the particles combine together to form a particle of helium due to the heat through a process called nuclear fusion, which happens inside the star. And this nuclear fusion makes the star stable, as we will see later. So here we have a simple diagram of the protostar with its core and surface. So the nuclear fusion in which hydrogen combines to make helium happens inside the core, and the helium which forms makes an outward force going out from the core and pushing the surface layer of the star outwards. But there is also the star's gravity which is pulling the star in on itself. So the forces of nuclear fusion and gravity. When they are the opposing forces and they are almost equal, make the star stable. This is called a main sequence star, and for the life cycle of a low mass star, an average star. So when the main sequence star becomes stable, it continues to use up its hydrogen in nuclear fusion. But eventually the hydrogen inside the core of the star starts to run out, and the nuclear fusion and gravity are no longer balanced. So the outer shell of the star, or the outer layer or surface, whatever you would like to call it, still has hydrogen left in it. So nuclear fusion still happens in the outer layer of the star, and it continues to expand outwards. Meanwhile, gravity overcomes nuclear fusion at the core, and the core becomes unstable, starting to contract and collapse in on itself, making a red giant star, which is much larger as the shell expands, and it glows dimmer due to less nuclear fusion. So as nuclear fusion continues, the outer shell of the star continues expanding and getting blown away. Now with due time, the outer shell and all its components get blown out so far that they form a ring or cloud of dust and gas around the core, which is similar to a nebula, and this is called as a planetary nebula. Now, at the center of the planetary nebula, the core was obviously still contracting, and eventually all the matter got packed into a dense and hot ball, which is known as a white dwarf. So, a white dwarf is at the last stage in the life cycle of a low mass star, and it is basically the leftover core of the star at the center of the planetary nebula. Now it is believed that over time the white dwarf will cool and turn into a completely cold and dark body called as a black dwarf. But we have not observed any black dwarfs in space till now, so it is completely theoretical. So this is where the life cycle of a low mass star ends, and you can watch part 2 of this video in order to find out about the life cycle of a high mass star.